Okay guys, real quick and easy, we're going to break down the quantum numbers of an atomic orbital and how this relates to the Pauli exclusion principle. Quantum numbers are a coordinate system that tell us where an electron is likely to be around the nucleus. We're going to use a simple analogy to explain this. Imagine we have a friend Paul who ran away from home. We're trying to figure out where he is and where he's likely to be. The first thing we want to know is how far Paul is away from home. Let's call this n. We also want to know what direction and how fast Paul is moving. Let's call this L. Next we want to know how Paul is oriented in space. Is he standing, is he lying down, or is he sitting up? The last thing we want to know is how Paul is feeling. Is he happy or is he sad? Paul is our electron and the house represents the nucleus. N is the principal quantum number and describes the distance from the nucleus the electron is likely to be. L is the angular momentum quantum number and describes the shape of where the electron is likely to be based on how fast and what direction it's moving. M subscript L represents the orientation of the shape in space, usually described relative to x, y, and z axes. M subscript S describes the electron spin, up or down. Very simply, the Pauli exclusion principle states that within a given atom, the quantum number coordinates are unique to each electron and that no two electrons can share the same four set of quantum numbers.